So the next intern presentation is been by a project with Pierre Tenedero. Now, due to unforeseen circumstances, he's not able to join us today, but the lead supervisor on the project, Petra Helmholz, will kindly give the presentation today. Pierre's just completed a Bachelor of Engineering in Mechatronics, and his project is photogrammetric analysis of the 4th century. I'll say that again. This is a wreck that's over 2,000 years old, that is being reconstructed from photographs that were taken in the 1970s. So thank you, Petra.
All right. Good afternoon, everyone. Thanks for staying for the last presentation. I was informed to give the presentation yesterday, so I try my best to run through all of the results. I was on the journey together with Pierre, so I think that will be of no issue.
I think we might be doing just shout, that's all.
I should yell? All right, let's try. I come a bit closer. What's about that? All right. So the topic is the assessment and analysis of the site diagrams of the Kyrenia shipwreck. So before I start, to provide some background, so the Kyrenia shipwreck is a shipwreck which was found off the coast of Cyprus in 67-69, was excavated. It is actually a shipwreck out of the classical Greek period, and I think we have an expert in the audience if you want to have further information about this. The main cargo on board of the shipwreck were amphora, and I believe that's, which is a button. That's the amphora. And you can see at the beginning there's a big pile of amphora. That was the first stage, what was excavated. That was lying on top of everything else. The hull on the top didn't exist anymore. This disintegrated over time. So what we could see, what the expert could see first of all were the amphora. And just to get an idea of the scale, they were actually quite large objects. Millstones were part of the cargo as well, and such a millstone is shown up here. And they have also proper size of 50 to 60 centimeters. When the shipwreck was excavated, images were taken during the process. And the images were taken sometimes just single images and sometimes stereo images, meaning there was a device where the cameras were installed on each side. So what has done in the past is I used a stereo plotter, as such a device, where you put the photographs in the device, and then you operate the device with some handles. What you can do is then you can orientate the images, and you can see it in 3D. So everything what you can see here is the same principle. What they did back then was they created a site diagram, as you can see over here, based on the images. So when they did the excavation back then, they took a number of images, lots of images during the whole period, and created those diagrams. So what Pierre did with the project is he took the images which were existing back then, tried to analyze them in 3D, doing a 3D processing, then tried to create the maps, the ortho images we call them, the photographic maps, but they're actually maps you can measure in them, and tried to assess if the site diagrams were accurate. Pierre's project focused on the excavation of 67, the amphora, as well as the excavation from 68 and 69, which were millstones. And I just broke it, I think. So he applied the standard photographic workflow. So what I want to point out on this slide briefly is you can see this lovely frame. This frame is placed on top of the amphora and the millstones in order to provide with a reference frame for the excavation. And one of the issues we had is the frames that kept changing. So in order to do an analysis of the 3D models, we have to mask them out. I think that was the most intense part for Pierre to do that. But otherwise, we put it in meta shape. We applied a normal camera calibration best practice in order to orientate the images, and we could create then 3D models. You can see on top a 3D model of the amphora. It doesn't look super fantastic. Please keep in mind that the images were taken in 67, 68, 69. They were never made to create this 3D model. And considering this, and also considering the lots of changes, so not a nice smooth surface, it's actually a pretty good outcome. So good enough for us to create the ortho images. And on the bottom you can see images of the millstones. And what you also can see is the location of the cameras when they was taken, the normal output of metashape. So in the next 3 slides, one of the main aims of the project was actually to create those 3D images, to create this 3D reconstruction. And the supervisor from the WA Museum was Jeremy Green, and so he was really happy with the outcome of the 3D reconstruction. So just to show you some of them, that's the amphora 3D reconstruction from the 67 excavation period. You can see them on the display in the wedge later on in 3D. Then this is the excavation of the 68 millstones, which you can see in the different locations here as well. And last but not least, we also could create this 3D model of the 69 excavation of the millstones. And you can see that's a flatter, we have more images, and you can see immediately the difference in the quality of the 3D reconstruction. What is quite interesting is, because sometimes the visibility is not really good, so if you actually stitch them together, you get the feeling of the whole site, which I think it's another nice effect for the museum as well. So what we did then, we have these 3D images. If we have the 3D images, we can create something called the ortho image, meaning we create a map, we create an image which has the characteristic of a map, so we can do measurements. And if you have the measurements, then you have something which has 3D, which has proper geometry. And then we try to overlay the diagrams. So that's in red are the diagrams, the site diagrams which were created in the 60s and 70s. And underneath is the ortho image which we created. So what you then can do, well, you can digitize the location of the millstone and other elements again. And then you can compare how good the site diagram actually was created. So what is the accuracy of the site diagram? So that was done for all 3 time points. So this is the results for the millstone 68. So what you can see in yellow is the outline which we have from the original site diagrams. What you can see in blue are the outlines of the millstones, how we captured them, how from the ortho images, from the 3D reconstruction. And you can see overall the location fits pretty well. All right, so all of the, you can find, well, that you find all of the millstone in the rough right location. Sometimes you can see different viewing directions. For example, this is my millstone over here. The blue one, come on. The blue one, you can see just the outline. Whereas of the yellow one, you can see the side element as well. This kind of error we can explain based on the signs which happen in the background. So the different viewing direction can be explained with different reference planes in the background and so on. So we are not concerned about this. We know where the error comes from, where the impact comes from. Which is interesting is more the difference in positional errors. So we know that some elements are rotated, some of them are actually shifted. And that's something where we actually can confirm that, well, there's a difference between the site diagrams created back in the 60s and 70s and today. And one element which was quite interesting, where this millstone on the bottom here. So millstones, they came in different dimensions. When they created the site diagrams back in the 60s and 70s, they had a look and said, all right, that should be a millstone of this and this dimension. And then they put the template into position. So what's happened here, they put the wrong template into position. So they put the template for a large millstone into position, whereas it was just a small millstone. So if you go through all of the recordings, you say there were so many large and small millstones, well, we can now verify if the data was correct or not. The scale is 60 centimeters, so each of the millstones is between 60 and 80 centimeters. We also did the analysis with the millstones from 69. Again, you can see some positional arrows. You can see quite a few up in this row over here. And in addition, if you look to the purple arrow, you can see again a different dimension. Looks like the dimensions again didn't fit. Previous slide I could provide with RMSE, so the residual mean square error. Sorry, I'm a surveyor, we always have to have something to quantify. In this case was 7 centimeters, so on average we are 7.4 centimeters off where we should be. We haven't created the RMSE for the millstone of 69 yet, that's still to come. And last but not least, the results for the amphora. Again, we haven't calculated the RMSE quite yet, but you can see with the amphora that the big amphora fit quite nicely, like here. But there are some areas where we have really significant shifts, again. So it's quite interesting to use actually 3D reconstruction to compare to the diagrams from the 60s and 70s. All right, so overall, we successfully could create the 3D reconstruction of all of the 3 sites. We haven't looked to the actual hull of the shipwreck, which was lying underneath the millstones amphora. That's something maybe to come later, or I think another research group works on this. We were able to then to create ortho images based on the 3D reconstruction. We were able to compare it, and we were able to actually analyze the accuracy of the site diagrams, or the difference between the site diagrams. And you can see, as mentioned, you can see the 3D reconstruction of all of the 3 excavation stages in the wedge afterwards. And with this, I would like to finish my presentation and hand over to Andrew again.